construct a B plus tree for the following set of values. And right now, for simplicity, the values are given in ascending order. Usually, this may not be the case. Right? Randomly, we may have the values, those we would like to insert. But as this is the first exercise, I have given you the values in ordered way. Right? And you are asked to construct a B plus tree for the cases where the number of pointers n equal to 4 and n equal to 6. So you are asked to build two B plus trees with n equal to 4 and n equal to 6. You take down this problem and I am going to explain how to solve this problem. Let's proceed now with the solution. So, I hope you must have pen and paper with you and you must have noted the problem. And as I stated, for simplicity, being this is the first exercise that we are working with, I have provided you the search key values in ordered way. In practice, you may have the search key values in any order. Right? Fine. So let's begin with building a B plus tree with n equal to 4. So we want to build a B plus tree with n equal to 4. Now, what is the first value that we would like to insert? Yes, what is the first value we would like to insert? 2. So we are assuming that our B plus tree initially is empty. Right? So what is our assumption here? Our assumption is our B plus tree is empty initially. And now we are going to add one by one these search key values in our B plus tree so that we can come up with a B plus tree index. So the first value that we would like to insert is 2. Right? We are having n equal to 4. So our node will look like this. 4 pointers. Right? As this is the very first node that we have created, this node is empty. We want to insert this value 2. So we'll be inserting at this place this value 2. Right? The next value to be inserted is 3. So obviously we have created this first node. In this first node we have inserted 2. Now we would like to insert 3. There is a space in this node. So we'll be inserting 3. Similarly, the next value to be inserted is 5. Once again, this is the very first node that we have in our B plus tree. We are having space for this value as well, 5. So simply we are going to insert that value here. So after inserting 2, 3 and 5, we'll be having one node wherein we are having these values stored 2, 3, 5. Got it? Yes?
Yes, ma'am.
Right. So what is the next value that we would like to insert? Yes? What is the next? 7. So we want to insert now this 7. So we are having this node with us. So obviously, as we are having this only node, we are going to insert this 7 in the same node. Now, this node is full. If this node is full, then we need to split this node. Right? So splitting this node means what? We need to create one more node. So this is our old node. And we are going to create a new node as well with same 4 pointers. Right? Now, we are arranging this value in order. So 2, 3, 5, 7 in order. Right? So, what is n? N is equal to 4. So, first n by 2 values, meaning first 2 values, that means 2 and 3. So, 2 and 3 will go in first node. Right? And remaining value 5 and 7 will go in second node. Correct? Are you getting me? Yes?
Yes, ma'am. Yes, ma'am.
Right. Right. Now, these two are the leaves now. So, we should have a parent for these two. Right? And right now there is no parent. So, we need to create one parent also. So, we have created this parent. Now, what needs to be stored in this parent? This is second node, right? So, whichever is the smallest key, that is 5, that we need to store here. So, this will go up, the smallest key from this second node. So, this will go up, right? And the pointers are being updated, like this P1 will point to this and this P2 will point to this. And obviously the leaves are connected to one another. So after inserting 7, we will have something like this. Got it? Any doubt? Yes? Any doubt?
No, ma'am.
May I proceed now?
Yes, ma'am.
So what is the next value that we would like to insert?
11.
11.
Yes, yes. So next value that we are going to insert is 11. So if I want to insert now this value 11, then I'll begin from the root node, right? So I will check for the search key value, right? Which is greater than or equal to the value that I want to insert. So this 11, I'm having in this root node only one search key value, that is 5, right? So all the values, those are greater than or equal to this 5 must be there in this node, pointed by this pointer, next pointer, right? So values, those are less than 5 will be stored in this subtree, and the values, those are greater than or equal to 5 will be stored in this next subtree. Right? So, I need to follow this pointer now, because this would be the correct place for inserting this value 11. So, after following this pointer, I will reach to this leaf node. In this leaf node, I am having the space available, right? So what I will do is simply I will arrange the search key values in ordered manner and I'll insert 11 here. Correct? So after inserting 11, I'll be having this B plus tree structure. Right? Now, what next? I would like to insert which value? After 11, I want to insert 17. Right. So if I want to insert 17 now, what should I do? Once again, I need to find first the appropriate leaf node. So I'll begin from this root node, right? 17 is greater than this 5. So I'll be following this pointer. So this pointer will take me to this node, right? So the proper place for this 17 is this node, this leaf node. But what I find is this leaf node is full, right? So this leaf node is full. So obviously I need to split this leaf node, right? So splitting of this leaf node means I'll be having now, instead of one, I'll be having two nodes. So this is the first node and this is the second node. So which are the values that I want to store in these two nodes now? 5, 7, 11 and 17. Those are ordered. So first n by 2 values, n is 4 here. So first n by 2 means 5 and 7. 5 and 7 will go in this first node and 11 and 17 will go in second node. Right? This node is already there. Please remember. And I am having this 2 and 3. So this node is as it is. Right? This parent also I am having. And in this parent presently I am having 5. So I have split this leaf node now. So according to the rule, whichever is the newly added node, the least search key value in this node should go up. Right? So in this node, I am having this 11. So this should go up. Right? So in this parent now, I am having ample space to store this 11. So once again, 5 and 11. So our order needs to be maintained. 5 and then 11. So I'll be storing this 11. Now, accordingly, I need to update the pointers. So this pointer will point to this node. This pointer will point to this node. And this pointer will point to this node. And obviously, these leaves are connected. So this is what we are having the B plus tree structure after inserting this value 17. Right? Are you getting me? Yes?
Yes, ma'am.
May I proceed?
Yes, ma'am.
Right. So now, what is the next value that we would like to insert after 17? We want to insert 19.
19.
Yes. So we would like to insert 19 now. So if I want to insert 19, let us do it here itself. So I want to insert 19. So see here, once again, I'll be referring to the root node. Correct? So 19 is the value that I want to insert. I'm having 5 and 11. So value to be inserted is 19. That is greater than the maximum search key value that is stored in this node. So obviously this pointer I need to follow. Right? 19 is greater than 11. So I need to follow this pointer and this pointer is taking me to this node. So whether there is any space available for 19 in this node? Yes. So what I'll do? I'll simply add 19 here. Correct? Now, what is the next node, next value that I want to insert? It is after 19. It is 23. Right? So once again, I'll be referring to this particular node, root node. So 23 is greater than 11. So I need to follow this pointer. So this pointer takes me to this leaf node where 11, 17 and 19 are stored. So I need to insert 23 in this particular node, but this node is full. So I need to split now this node. Right? So what will happen now? I'll be splitting this node. Okay, the earlier two nodes will be as it is. Where I am having 2, 3 and 5, 7. So these two nodes will be as it is. Okay, now in this node, I want to insert 23. So if I order these values, I am having 11, 17, 19 and 23. So first n by 2 values, meaning 2 values will go in first node 11 and 17 and remaining values will go into the second node, so 19 and 23. Right? Now obviously according to our rule, so we are having this parent which is the root node and I am having here 5 and 11. Right? So this 19 should go up. This 19 should go up and there is a space to store that. So simply we are storing 19 over here. Right? And now we are having the pointers. This pointer will point to this. This pointer will point to this. This pointer will point to this. And this pointer will point to this. Right? Any doubt so far? Yes?
No, ma'am. No, ma'am.
Okay. So now the next value that we would like to insert is 29. So we'll be referring to this root node. So which pointer to be followed for 29? Yes. Which pointer to be followed for 29? Yes. Please pick up. In this root we are having 5, 11 and 19. Right? And we want to insert this 29. So which pointer to be followed? 29, that is the value under consideration, is greater than this last value 19. Correct, no? So obviously we need to follow this pointer. Right? So this would be the appropriate place for 29. And we find that there is one empty space available in this node, leaf node. So what we are going to do is we are going to simply store this 29 here. Correct? Yes. Is there any doubt?
No, ma'am.
Right. So the next step is what we would like to insert. I think only one element is remained. After 29, we want to insert 31, right? So let us follow the process now. See, this is our root node. So we need to follow this process. So we want to insert 31. So 31 is greater than this last search key value 19. So once again, we need to follow this pointer. So this pointer will take us to this leaf node. So this leaf node is full, right? So the first important point is we need to split this node having the values 19, 23 and 29. So let us first do that. Okay, so we are splitting now this leaf node into two nodes, right? So what are the values? Those we are storing 19, 23, 29 and 31. So in ordered way. So first n by 2 values. So first two values will go in first node 19 and 23. Next values will go in this node 29 and 31. Now according to, so these three nodes will be as it is. So we are having 11 and 17. We are having here 5 and 7. And also we are having one more node where 2 and 3 are there. Okay, and we have split this node into two nodes. So obviously, according to our rule, what we need to do? The smallest search key value from newly created node, leaf node, that should go up. Now, what is there in its parent? See here, we are having 5, 11 and 19, right? And now we want to have this 29 added into its parent. Okay, now this is a non-leaf node and now this non-leaf node is full. Please listen to me carefully. We want to store this smallest search key 29 in its parent. But whenever we look at this parent is full. So what we need to do? We need to split now this parent, right? Which is a non-leaf node. So far, we have seen how to split the leaf node, right? And now we are going to see how to split this parent node. So parent node is full with 5, 11 and 19 and we would like to add 29 in this parent node. As this parent node is full, what we are going to do is we are going to split this node. So meaning instead of one node, now we will be having two nodes. Right? And what are the values? Those we stored 5, 11, 19 and now we would like to add 29. Now, as I stated, splitting of a leaf node and splitting of non-leaf node is different. Right? So, what we are going to do next? See here, we are going to follow the steps in our algorithm. And what are those steps for splitting of a non-leaf node? We are going to copy this entire node, right, in a new temporary node with n plus 1 pointers. So meaning I'll be having now 5, 11, 19 and 23. Earlier we had n pointers. Now this is my temporary node and in this temporary node I'll be having 5 pointers and this is the order of the values those I would like to store. Right? Now what I will do is, see here, this is my P1, this is my P2, P3, P4, right, in this new node. Okay, now what I'm going to do, n is actually 4. And for this new node, I have created a node with n plus 1 pointers. That means 5 pointers. Right? So what I'll be doing is, I'll be copying from P1 to Pn plus 1 by 2. P1 to Pn plus 1 by 2. This much data I'm going to copy in the first node. Right? So what it indicates, n is 4. So 4 plus 1 means 5. 5 by 2 means 2.5. And ceiling of that means 3. So from P1 to P3, I am going to place in this node. So I'll be putting 5 and 11. P1, P2, P3. Up to this part I'll be putting here in the first node. Then what I will do is, I will skip after 11. I am having here this 19. So I'll skip this value. And what I'll do next is, from this pointer onwards, whatever I am having, I will put it in the new node. So sorry, this is 19, not 23, it is 29. Okay, so what ultimately I'll be doing, 5 and 11 will go into this node. I'm keeping this intermediate value 19, right? And the next, I'm having this P4 pointer along with this value 29. So this remaining part will go in this node. So I'll be having here 29 and this pointer will go here. Okay, now what to do with this value that I have skipped? Now, as I have split this parent node into 2 nodes, I must have some root. So I'll be creating one root node here. Okay, and this value that I have skipped, 19, this value will go into this parent. Now, see here how I am going to update these pointers. This pointer will go to this, right? And this pointer will go to this. So the values less than 19 will be here. The values greater than or equal to 19 will be in this node. Okay, now these pointers also will be updated accordingly. So this is 11, so this will point to this. This 29, so values less than 29 and values greater than or equal to 29. And these leaves are being connected. Right? So this is what our final B plus tree for the given data. So please note here the process for splitting the leaf nodes and the process for splitting the internal nodes, non-leaf nodes, is different. And that is what I have demonstrated right now. If you have any kind of doubt, please let me know. Yes. Have you understood? Yes.
Yes, ma'am.
Right. So please once again go through the steps those we have followed. Right? And I'm giving you one homework. So also you were asked to build the B plus tree for n equal to 4 and n equal to 6. Right now we have come up with a B plus tree with n equal to 4. So you please try with the same data, create B plus tree with n equal to 6. with the same data. Right? And I'm giving you one more exercise. So please take down this problem statement. Note here, we would like to insert the search key values in this order only. So first we are going to add 8, then we are going to insert 5, then we are going to insert 1 and so on. Right? In the first exercise, we had our data that was ordered. Right? But in this example, our data is not ordered. So do not order this data initially. Please remember, whatever is the data, in the same sequence, we need to insert the data in our b+tree. So don't order the data first. Right? So you begin with adding 8, then you go for adding 5, then you pick this value 1 and go for adding 1 and so on. Right? And you are supposed to construct a b+tree where n equal to 3. Right? So this is the homework for you. And I hope you will be able to come up with the solution. Right? While providing the solution, you need to provide the steps as well. Similar to this. Don't directly jump to the solution. Whatever are the steps those we are following, you need to specify those steps. And finally arrive at the solution. Okay? So try this problem. If you have any doubts, please let me know. Otherwise, we are going to conclude the session. Yes, any doubt?